Hello, folks. This weather topic video is going to be going over something that I've had on the back burner for a while because I didn't know how to cover it. And I was like, you know what? Might as well just do it because then I don't have any better ideas. So here we are. Rapid Tropical System Intensification, just shortened to Rapid Intensification, is used to describe a tropical system that is rapidly increasing in wind speeds, simultaneously decreasing in pressure because that is just how low pressure systems work. You might be asking what rapid intensification truly means if you've never looked it up before, and understandably so. The problem is that there is no official definition. We do have two general definitions, both by the US for the most part. The first one, done by a around 1995-ish paper, is a wind increase of 30 or more knots, that's roughly 35-ish miles per hour, within or in 24 hours. This includes 95% of all rapid intensifying storms ever reliably recorded in the Atlantic basin, which actually sees some of the largest amount of rapid intensifiers, but that doesn't really mean a whole lot. We'll get to that in just a little bit. The very end. The second one, the second definition, is actually from the National Hurricane Center, the NHC, which states a 42 millibar pressure drop within or in 24 hours. It is worth noting that the 24-hour mark is just a good frame of reference for the human span of time because, you can't really say that a storm has rapidly decreased in pressure in just 6 hours when it strengthens because that's just what hurricanes do when they strengthen. They're going to drop in pressure. So this 24-hour mark really gives just a good sense of time and just a good start and end point. It is worth noting that rapid intensifying storms can rapidly intensify for as short as 3 hours to 6 hours, but most usually last longer than 24 hours or a little bit under 24 hours. Some examples, however, we're going to be looking at examples here, is 1992's Hurricane Andrew in the Atlantic. Andrew reached a maximum of 175 miles per hour, 1 minute sustained wind speeds, at 922 millibars in pressure. Andrew went from a tropical storm to Category 5 within roughly 36 hours, which is insane. That's at least, we'll say, 74 miles per hour to 157 miles per hour. That's the maximum tropical storm strength to the minimum Category 5 strength, and this was over the northern Bahamas, close to Florida. Andrew, at the same time, experienced a pressure drop of 47 millibars. Hurricane Katrina happened in 2005, is the world's costliest tropical cyclone ever reliably recorded. Technically tied with Harvey, I'm not getting into it. Katrina experienced a rapid increase of advantageous conditions after it struck Florida as it was entering the Gulf of Mexico. Katrina actually experienced two separate bouts of RI, rapid intensification, with an 18-hour lull in between them because it underwent, thank goodness, an eye wall replacement cycle. Obviously, this eye wall replacement did not stop Katrina from intensifying further. However, it underwent a second eye wall replacement cycle pretty soon after reaching its peak of Category 5, thankfully down to a Category 3. This did not stop Katrina from causing massive damage in Louisiana, however, as it is obviously infamously known for. Hurricane Wilma, also in 2005, also reached Category 5 strength. It seems to be a trend here. Wilma went from 70 miles per hour strong to 175 miles per hour strong in 24 hours. In that same 24 hours, experienced a pressure drop of 96 millibars. In 6 hours, Wilma experienced a 54 millibar drop in pressure, and in total, a 100 millibar drop in pressure in 30 hours. Wilma is also best known for 185 mile per hour winds and the smallest known eye ever reliably recorded of any tropical cyclone at just 2.3 miles wide, just shy of the largest tornado ever recorded, which is really weird to think about. Anyways, in the East Pacific, we have 2015's Hurricane Patricia. Hurricane Patricia has the fastest reliably recorded 1 minute wind speeds of any tropical cyclone ever, 215 miles per hour. Patricia's rapid intensification was very highly anticipated, but was just poorly forecasted. In 24 hours, Patricia experienced a wind increase of 120 miles per hour and a pressure decrease of around 95 to 98 millibars. Damn. 2023's Otis is a special case here. Otis happened in roughly the same ish area as Patricia, just did not have the same path. Otis happened a little bit further north towards Baja California and the states of California. The biggest problem with Otis was the immense lack of data that NHC had in the region. It was not anticipated to reach Category 5 strength until it was already Category 5. Otis went from low end Category 3 to its peak of 165 miles per hour in just 9 hours. Crazy. Lastly, here for the first page of examples, yes, we have more since I want to be thorough, is 1979's Typhoon Tip, which reached Category 5 equivalence. This is using the Saffir-Simpson wind scale, by the way. The Australian basin uses category scale as well, but we're using the Saffir-Simpson scale category. Tip has two separate records: the lowest reliably recorded pressure ever seen in any tropical cyclone ever, at 870 millibars, and the widest both cloud size and wind field ever reliably recorded from any tropical cyclone ever, at what is it, like 2,000 kilometers wide in all? Crazy. Tip had a very rough start to its life. It almost didn't make it numerous times. However, after escaping the clutches of high pressures, Tip was in a very favorable environment very suddenly, which caused Tip to rapidly intensify. Wow. Tip experienced a pressure drop of 92 millibars in 48 hours and went from Category 1 equivalents to Category 4 equivalents in around 24 hours, a little bit below that. For the North Indian, South Indian, and Australian basins, we have 1999's Odisha cyclone, the most intense North Indian basin cyclone ever reliably observed, at least in terms of pressure. It went from tropical storm equivalents to Category 3 equivalents in just 9 hours, and then slowly went to Category 4, then went to low end Cat 4 to Cat 5 equivalents in 3 hours. Rough. Odisha was a little crazy. 2013's Hurricane Fallon, I don't know how to pronounce that. I'm American, I'm sorry. Went from Category 1 equivalents to Category 5 equivalents in just under 24 or so hours. Again, crazy. A storm I actually had no idea about until researching for this was 2019 Cyclone Ambali. Ambali is pretty significant actually, with one of the highest increases in wind speeds in 24 hours ever observed, 110 mile per hour increase in wind speeds. and a 50 millibar increase in those 12 hours. That is one of the highest increases in wind speed in the southern hemisphere outright, or just straight up in the world, like I said. 2023's Cyclone Freddy is probably never going to be beaten for a few things. While not the longest traveled cyclone, that still goes to Hurricane John of 94 in the East Pacific. Freddy rapidly intensified a record number of times at 7 times, so I'm not going to list even a single one, because now I want to be thorough and I want to list every single one. There's too many. Freddy is, however, the longest lasting tropical cyclone, and just wow, Freddy was a beast. Lawrence, 2009's Australian Basin's Lawrence, is an oddball for rapidly intensifying into Category 4 equivalents from Category 1 equivalents 2 times, something that normally does not happen. And last but not least in our examples here is 2018's Marcus, which peaked at Category 5 equivalents, which 24 hours before it was Category 1 equivalents. This system is actually the exact opposite of the significance of Otis. Marcus is actually one of the few successful predictions of rapid intensification, which is very good because fundamentally, when you look at rapid intensifiers and non rapid intensifiers, fundamentally there is no difference in the conditions. Very similar to tornado genesis, actually. What I can at least pretty much guarantee you, however, is that RI is dependent on the surrounding conditions. There are some internal factors, absolutely, but a majority of them are external. What we really see is just a lack of inhibiting conditions, so lack of shear and dry air and proximity to land, stuff like that. We saw with Katrina and stuff like, actually, really, Katrina is one of the few examples here. Odisha is another one, Freddy as well. We also see a rapid onset of advantageous conditions. We saw this with nearly every single one of our examples, or we saw both of these. Usually it's actually a combination of both, which you would think would make it easier to predict. But again, fundamentally, there's not a difference, which is the problem. It does not help that only 20 to 30% of all tropical systems will even rapidly intensify. Kind of like tornado warning. If you constantly shout that a storm is going to rapidly intensify and then it doesn't, you're going to lose some trust. That's just how the human psyche works. It's the boy who cried wolf, you know. The same thing is for tornadoes, with roughly three-fourths of all tornado warnings being false alarms. However, in that case, I'd still rather be safe than sorry. But anyways, rapid intensification is actually most common with tropical storm equivalent systems and roughly mid to upper category 3 equivalent storms. It's not really common with category 1 equivalents or category 2 equivalent storms, even which is just another wrench in the whole prediction thing. Obviously, all of these things combined make it extremely difficult to predict, with successful prediction, of course, extremely rare. However, of course, as we learn more about this and as we get closer and closer into cracking the nitty gritty details, we will be better with this. Obviously, surroundings analysis is pretty much necessary for this kind of thing, in my opinion. But that can be really hard sometimes when you just may not have the available technology. Yes, we have, the GOES 1819, whatever goes we're on nowadays, that satellite, those satellites, I should say. But when you may not have moisture mapping, or you're obviously we're just focusing on that storm and not the surrounding conditions, our eye can come up spontaneously, it seems like, when it may not. Again, we're just going to need to get closer and closer to cracking the code, which is what we're doing also with tornado genesis. Because you can have all the right conditions for both the rapid intensification and tornado genesis. Say, a lack of shear and a bunch of moisture and a bunch of lift, and it's going into all of this, and all of a sudden the waters aren't warm enough, and then nothing happens, or this happens. There's not enough of this, there's not enough of that, whatever. It is very complicated, which is why I am certainly not qualified enough to wholly talk about it, but I still wanted to give at least a good ish um, video on this subject. In any case, I thank you so much for watching, and all the sources that I have will be in the description for this video. I'll have to see you all in the next one. Thank you all so much for watching.